Hello, everyone. Today we're going to talk about no-nonsense observability improvement. If you came here looking for nonsense, I believe that's a different talk. I don't want to disappoint you, so we'll just get that out of the way right at the beginning. The genesis for this talk, which I'm going to talk a little bit more about in a second, was that I work for a vendor, and I didn't used to work for a vendor. And so I got a lot of opportunities now to talk with customers. And so my initial thought was all the fun and exciting conversations I have when people are trying to find out if they want to buy an observability product. But eventually it morphed into something different. It morphed into after you have some observability, I think in the abstract it says, so now you have observability at your company. So what's day 2, day 3, day 4 look like? And so this is mostly going to be a talk about how to get more value out of observability, how to talk to leadership, how to talk to your peers, how to talk to teammates, because at the end of the day, I believe this to be more of a social problem than it is a technical problem. But unfortunately, we tend to look at it like it's a technical problem. So why should you listen to me? That's me. I am Cory. I work for Splunk. I am a technical evangelist. But previously, I worked for SignalFx. We were acquired by Splunk a few months back. And my role at SignalFx was was the technical director in the office of the CTO. And so I basically got to have a lot of pre-sales conversations, a lot of post-sales conversations, Cory's done a lot of observability before. Let's talk to him and figure out how to deploy this. A lot of product conversations about what the product should do. Because leading up to this, I previously had worked at Stripe, where I was the principal engineer and where I created and led the observability team. I forgot to start a timer, so we're going to do that now. Ooh, reset, start. And there, I bought a lot of these tools. I was a customer, not a vendor, which is a whole different kettle of fish, right? And then before that, as you can see up here, I also worked at Twitter, where I was an SRE, and then later was an engineering manager for the observability team. And there we built our own stuff. So if you're thinking about building, buying, running open source, doing any of that stuff, I have done all of those things at a whole bunch of different companies, and I have a lot of scars to show for it. And I've talked to a lot of, maybe even some of you, about your choices about doing one of these things. If you want to find out more about that kind of thing, occluded by someone's head, at the bottom left, you can find, it's okay, yeah, lean down, there you go. There'll be later slides for that. Just frame it for me, like put your hands around it. Great, audience participation. All right, you can find more about me there. Got to roll with it. No live demos, but this is the version I get. So today's goal is to find useful, vendor-agnostic ways to improve your observability stack. If you're expecting me to tell you how to name your metrics or to tell you why tracing is the coolest thing that you should be poking at or any of that kind of stuff, it's not what we're going to be talking about today. We're mostly going to be talking about the social aspects of the work that we're doing and how we can try to make ourselves more prepared for the conversations that we need to have inside the organization. So the first part of this is sort of why we observe. If you've ever gone to any talks on observability, if you're interested in the space, you know that this is the part of the talk where someone defines observability. I'm not going to do that today. I'm instead going to talk to you about the conversation that you're going to have with the organization. So like if someone asks you, why do we need to buy one of these tools or something like that. So this is my favorite graphic for articulating why we have observability in the stack. Some people often ask me, like, I thought we had monitoring. Wasn't that a thing? Didn't we already have monitoring? How is it different? Well, monitoring is because you traditionally know what you're paying attention to. I have it on good. I'm pretty sure that it's going to happen. I've heard this. Maybe you've heard it too. In 2020, disks are still going to fill up. And we kind of already know that, right? So we monitor for disks to fill up because that's something that we anticipate happening. The problem is there's a lot of stuff in our stacks that nobody really ever anticipated. And the point of observability is to prepare yourself for the inevitable possibility that stuff is going to break, things are going to fail, and you're not going to have anticipated what it was. I'm sure many of you have been in a situation where you got called or you got paged, and the thing that broke was something you had never thought of happening before. Observability does not make those things transparent to you. It is not magic. It's not a silver bullet, but it does prepare you for the fact that when things are broken, you are more likely to find some of those breadcrumbs or something like that that will get you into the right place. So the unanticipated things are where observability tries to help. I like to call this for when shit gets weird, because that's typically what observability is more valuable for, not for the things that you already expected to happen. That's just monitoring. So the next reason that we need something like this is that the systems that we're building just keep getting more complicated. Systems are complex. not only are they complex, but they're complex in actually sort of academically interesting ways. Systems are nonlinear, meaning that the inputs that you give them can result in varied and wildly out of proportion outputs. They're chaotic because the inputs they're very sensitive to. A slightly different input can result in a really weird output. And then lastly, they're emergent because these weird human things keep getting involved in these systems and setting up weird little microservices that interact with other little microservices, and before you know it, you've got this big complicated system that seems almost alive by itself. And trying to deal with this stuff is pretty difficult for humans. We have to learn how to deal with it and the complexity that it entails. So another graphic. Many of you are responsible probably for some sort of service that you've written. Maybe it's request-based, and you know that a request-based service can usually be in a couple of simplistic states. So we've got like waiting for a response, like listening. We've got processing, we've got responding, and maybe we've got shutting down. So that's 4 states that your system can be in. And humans are pretty magical. We can look at these things and diagnose them and understand them and make mental models about how we process them. And then we can do even more interesting things where we create robots or automation or some sort of system that even monitors or manages the system for us, right? But the complexity to this is that this little robot that starts off so simple actually becomes fairly complicated. And before you know it, the robot needs to understand every single state that your system can be in. And so there happens to be, which I am probably going to butcher, but there is from cybernetics a thing called the law of requisite variety that says that for a controller to properly control something, it needs to understand more states than the system it's monitoring. So even the systems that you are building to monitor the things that you are making need to be more complex. And the systems that we use to administer and watch them get more complex in turn, which this is really just a whole lot of explanation to help your CFO understand why in the world you're paying so much for your observability tools. But at the end of the day, the interesting thing about this, there's a pithy little statement in the paper that says variety defeats variety, which I think is very interesting because for us to run complex systems, we need complex tools. So this was a talk about observability, I think, so we should probably bring it back to that. So why do we need observability for this, and what can we do with observability to make it better? I don't want to go to that slide yet. So instead, I'm going to stop and say we need this observability stuff because it is effectively a counter to complexity. It's a way to deal with the fact that as your systems get bigger and badder, and as you are responsible for way more containers or service meshes or Kubernetes or whatever this conference is about, like things get complicated and you've got to learn to deal with that, and observability is there to help you. So I'm going to go through 6 different bullet points of things that you can do to try to make your observability stack better. This is the one slide that doesn't have any other slides that go with it, because I don't know how to tell you to do this. Everybody's got a different way of doing it. But the number one thing that I would encourage you to do is to promote the work that you and your observability stack is doing. This is primarily aimed at people, by the way, who are on an observability team or want to encourage the use of observability in their organization. If you want to know what observability is or why, again, that's not in this talk. But the point is to get you to think about how to improve. And the first way is to make sure that people know about the work that you're doing. If you're not telling people about this work, why you're investing in it, what the wins are, what the gains are, then how is anybody supposed to know why you're investing in it, right? And we're going to come back to this and talk to leadership in a minute. We're a few more slides along. So, oops, that went too fast. So now we've got 5 things that we're going to talk about. Each one of these do have real slides that come after them. So number 2, teach basic skills. How many of you write job descriptions for people that you hire at your companies or have contributed to them? How many of you put a bullet point in it for you need to be able to create, digest, or do anything with your observability stack? A lot fewer hands went up. We don't really teach this, right? Like I learned it all just kind of on the job. I learned it because I couldn't remember how anything worked, and I felt better knowing that I had things keeping track of it for me. The problem to this is that your first interaction with many of these tools, like let's say I join a company, I'm there for a few weeks, got my laptop provisioned, I rolled code my first day, and then I get into an on-call rotation and suddenly I'm thrown into a problem. And if your first interaction with an observability tool is at 3 o'clock in the morning under duress, do you think you're going to be particularly happy with that observability tool? Like that's a really crappy way to learn. So to help people with this, we need to actually teach them something up front. Now, I want to preface this by saying don't expect people to learn your entire observability stack or really even retain almost anything that you tell them in this spin-up class or this, however you do it at your company. But that's because humans learn by doing things, not by watching them. You have to actually sit down with it, the mouse in hand or your keyboard or whatever you do, and you actually have to make this stuff. But we can help them get started. In fact, most of the education things that your organizations have when you bring people in, it's not meant to get them to exhaustively understand your entire company or your entire stack. It's just to get them to understand some of those basic words and some of those things that they're going to see later. So we can teach them how to navigate the tools and the products and what's out there. We can teach them about how to find metrics, traces, log lines, spans, whatever those things are. We can actually show them how to do it. Any of the common frameworks or libraries or things that your organization uses to make this more easy, these are things you can also teach. And I can sort of run through this whole list, but I'm just reading the slide to you. The one that I think is important at the end is to plug your way of doing it. How are you different? Most of us are probably lightly familiar with, oh yeah, we've got a stats library, or we emit spans this way, or log lines pop out like that. But what do you do that's special? And let's make sure we're teaching that to the people that are in the class. And then the next part is, since we don't learn by just looking and being talked to, how do we make sure that we're practicing and that there's something for people to do after they leave your class? So the next thing we have to focus on is genuine practice. The only way you're going to get better at this stuff is by using it. And so we need to make sure that people have more things that they can do on sort of day 2 or day 3 so that they get out into the world and they start using these tools on a regular basis. They need to be using to solve problems, to see what's going on in the systems or what have you. What can they do week over week over week? Because we want this to be something they're constantly investing in. This is where the promotion of the work becomes important too. If you're shipping cool new stuff in this, are we telling people? Are we letting them know, hey, you need to come check this out. You need to see these new features that we've added. I like to use martial arts as an example. I will also say that I do not know any martial arts, so I'm mostly making this up. So if I get it wrong, you can just not tell me after. It's fine, because it's just an illustrative example. But the point is, many people go into martial arts because they have this idea, I'm going to go and I'm going to be some nth degree black belt or something. But the truth is that expertise is not evenly distributed in organizations. And you have to expect that the people who learn from you and who work in the company, you're going to have some people who are black belts and some people who just know the basics. And there's nothing wrong with that. But we need to facilitate this sort of progression over time, that there are people that you're helping who are getting that black belt, but also people who have the basics. And we need to remember that. Not everyone is going to come in and become a black belt in your observability stack. They probably have more interesting stuff to do. So number 3, we've talked about promoting our work. And we've talked about whatever the last one was, I forget. So now we need to stretch our systems. So what do I mean by stretching our systems? Improvements in capacity, this is a law that I'm ripping off from somewhere. It's paraphrased heavily. But improvements in capacity are consumed by productivity and efficiency. If a new programming language comes out tomorrow and it allows you to do the same things that you're doing today in half the RAM and half the CPU, you're probably not going to adopt it. Because, I hate to break it to you, but pretty much all of you are using language that there is a language that is twice as fast and twice as efficient. But you've chosen not to because it's more efficient for you. You're more productive if you use these other tools. And the same goes for the systems that we build. If tomorrow someone on your resiliency staff makes some changes and adjusts some things and adds some new capacity, you are almost certainly going to consume it very quickly with cool new features that your users ask for. And that's okay. But we need to learn how to do the stretching ourselves. So optimally, we are not learning how to break our systems from our customers. One of my pet peeves of observability and something that I encourage people as a vendor to not sell is we are not going to make incidents go away. We're only going to sort of help you understand the impact of them and maybe help you communicate about them better. If I'm on a bridge and the bridge collapses, the Department of Transportation will not know before I do. That's just physics. And it's the same situation here. So optimally, we need to find ways to take the data that we've got and feed that back in and make our systems better by sort of doing the stretching ourselves. I always have this visualization of using shoehorns to stretch things out, and I was doing the practice talk this morning and realized that this made no sense, so I'm just not going to use that. But the idea is to feed things into your resilience stuff. If you've got load tests, chaos tests, game days, all these other types of things. At Stripe, when I was there, we had a team called Load and Fault, and their whole job was to look at the next Black Friday and say, what's that going to look like? And let's go ahead and start stretching and pushing on the systems and fixing the things that we find in the process. And by doing that, we are creating a lot of value from our observability stack because all the tools that they use to visualize, understand, even control the system, if they started to see too much impact on the system by using the observability tools, they would be able to dial that back or turn the test completely off. And again, that's something that our observability stack is doing. They can't get that anywhere else. Also, if there are things that you find in incidents, like if you're ever watching an incident review and somebody says, whew, I'm glad that didn't happen, that is an excellent way for you to find something to use for a game day or something else to sort of stretch out your systems. So number 4, we got to measure usage. This is the big one that finance wants to talk about Because at the end of the day, these tools, and by the way, you may think I'm talking about this from the perspective of a vendor, that like what the vendor costs. You may not be thinking about it this way, but your OpEx and your CapEx is still money getting spent. So even if you build this in-house, if you build something from open source, all these things are still going to cost you money. You're still paying full-time engineering salaries, or you're still reserving instances, or whatever you're doing. So I can tell you right now that observability will probably be one of the most expensive parts of your company. Whether it's something you built or something that you bought from other people, at every company I have ever worked, it has been the most expensive thing in the stack. Well, other than like, the company. So what you need to do is start measuring usage up front. Even if you are using something open source, you need to know where the money is being spent. So the first things we need to start doing is start grouping things. What services did this information come from? Logs, metrics, spans, doesn't matter. What team was it associated with? Because then we can start thinking about chargeback and showing people what they're using, especially relative to their peers. We had a big initiative at Stripe where we actually started measuring, keeping up with what people are using, and we were able to cut metrics 50% year over year just by recognizing what people were doing and talking to them. We didn't even take anything away from them that they were using. We had just never actually looked at what was being emitted. I remember at Twitter, 99.8% of metrics that were written never got read back out again. And that sort of information is really hard for finance to understand because they don't know why it's sitting there. So you can also group by region, by geography, by cloud, where you're assigning costs. You can also probably find a friend in finance who knows, that had a lot of F's in it, who knows a thing or two about money and ask them to come over and help you with this stuff. They love to teach that kind of thing. Lastly, comparing what you are spending to how your organization is growing is another great metric. So how much are you spending on infrastructure? Is that going up? Is it getting bigger and having more of them? Well, that's going to increase your complexity. You will spend a proportionate amount more because of that. I'm not sure what that percentage is. It's different for every org. How about dependencies? The more interwoven your systems get, the more things that are hooked together, the more flows and connections you make between things, the more Envoy metrics come out of them, as an example. That sort of stuff, like it's going to cost you more because you need that visibility. You want to be able to see those things. When things get broken there, you want that visibility. So be sure to feed that back to your team, your leadership, or what have you, because as you are increasing complexity, that's going to cost you more as an observability team. Also, you can compare this, I'm not sure how that one got so big, you can compare this to changes over time. If you're an organization who only ships code once a week, and suddenly you start shipping code 5 times a day, you are probably going to end up generating more cost in terms of observability, because more changes to the system means more output from it, and means more things that people are going to want to investigate, because change inevitably leads to problems. So we also need to measure not just how much people are sending in, but also how much people are pulling back out. So a good example, to go back to monitoring that we talked about earlier, if someone's monitoring a metric, that's a pretty good signal that that metric's worth something and that it's valuable. You may also be able to pay attention to incident investigation. So observability is always very closely associated with keeping up with incidents, but you also need to be looking at what did people do during these incidents? What were they using? Were there a series of tools that were used more than others? This is also some information that you don't just use to defend your position of like we have a big observability stack. It's also how you can make internal decisions when you know you need to shrink or grow certain aspects. Maybe nobody's using that logging platform anymore. Maybe tracing didn't pay off the way that you expected it to. That's okay, but you're not going to know unless you're paying attention to how and when people use the tools. Game days, chaos testing, all that kind of stuff, these are also things. It doesn't just have to be incidents. These are things that hopefully you're doing inside the company anyway. I'm not going to tell you how great chaos testing is. There are plenty of other talks for that. But dashboards are another big one. We keep making all these dashboards. If a metric's in a dashboard, that's also something that's valuable. How do you encourage the use of that more? I mean, we're not selling ads in these dashboards yet, at least. I don't think anybody has any plans to do that. But the more eyes you can get on them and the more you can push people into them, hopefully the more people are seeing those and the more value that you're deriving from those metrics. Lastly, just keep going with this. Where are places where you can use this data inside your organization? We did a pilot program once at a place that I worked where we used tracing data to generate cost data to say how good were our margins on some of these. Like, are we charging too little or too much for some of these queries? Because if they're long runners, we might be able to take the fact that we know the spans and what machine they were on and how much the machine costs to generate budget information. And that's something no one had thought of before. So number 5, we also need to track need and detail, which is just a fancy set of slides for incidents is what I'm about to talk about. So observability, I've already said, closely associated with incidents. Many times this is where we start to push like MTTR and MTTD as metrics for how to have observability improve your organization and how things are working. So the reason we need all this is because complex systems are hazardous. like the fact that you've just got these big amalgamations of services. They are just intrinsically dangerous. They change a lot, as you know, and they require experience with failure. The only way to learn about failure is to fail. That hasn't changed yet, and it doesn't in our business either. So how many of you have incident management programs at work? I'm guessing that your incident management metrics are probably bad because they're probably the ones on this slide. No offense, we can talk about it after. But MTTD, mean time to detect, for those of you that aren't familiar. Mean time to remediation is another metric. Timestamp, the duration of an incident, who got it, how severe it was, the proverbial root cause that doesn't really exist. These are all things that you're probably tracking in your incidents, and this is inadequate. This is at best just like a sort of high-level measure that stuff happens and confirming that stuff continues to happen. It's not to say that improving MTTD or MTTR aren't goals that you should have, but this is definitely not enough information. So instead, I'll make some suggestions for things you should track. Most credit for this slide goes to Nora Jones. Many of you may know Nora Jones and her work in chaos testing and safety and systems. This was almost completely ripped out of one of her talks at Monodrama Baltimore a few weeks back, which I suggest you go check out. But if you want to actually learn something from incidents, and these are all things that your observability stack can help with, these are the types of things, as a suggestion, that you should start measuring. Things like, where are people saying stuff like, how does that work? Like, just going back and reading the chat logs when people are dealing with incidents can be a gold mine, because things like people expressing surprise is really, really interesting, right? Like, we could go back and investigate that more. How about tracking all that stuff that you're tracking for the high-level part of your service at every individual system? What's the MTTD or the MTTR of each of these systems? Do we have systems that aren't failing? Because that sounds like something you should pay attention to. One of the downsides of these incident management programs is all that you're doing, by definition, is monitoring the incident or the failure. You are spending a whole lot of your day generating success that you also need to compare. Something called the halo effect and the horn effect. Like, the halo effect is that when you only monitor success, you only learn about success. The horn effect is that if you only monitor failure, you only learn about failure. We have to mix two of these and see what we can learn. What's happening in successful things, or what near misses did we have in those successful operations? Nobody likes surprises when it comes to incidents, so that's definitely something you should pay attention to. Also, the fact that you keep creating these dependencies. When dependencies vivify? When do new edges show up in the graph? And when do we get connections between teams that were no longer connected? I'm not going to read everything on this. I pretty much already did. But the point of this is that there's a lot of really interesting questions you can ask about incidents that are well beyond these simple qualitative metrics that we feel comfortable with, over into qualitative, which we're perhaps less comfortable with as engineers. This is also a great opportunity to get a lot of feedback for doing the internal stretching yourself, because there's so much to learn from near misses and incidents, or what people say even about successful operations. Number 6, we are almost through them all. This is the last one. So the next part is instrumenting change. At the end of the day, the real goal that we mostly have is not just to create some system that's static, that just sits out there and processes things. Even if you're not changing your system, your users are. Because users have this really pesky habit of finding interesting ways that your API maybe wasn't intended to work, and then coming to rely on those features. And so even the shape of the way that your users are handling the system changes over time. So pretty much every tool that we build has a y-axis, which is magnitude of change, and then it has an x-axis, which is time. The problem is that time's not really what breaks stuff. Like, the passage of time in and of itself, this is a very heavily paraphrased quote from Edward Tufte, who does a lot of visual display, and that was unnerving. Hopefully that's okay. The passage of time is not the mutator in systems. It's not what breaks stuff. Humans and robots are what tend to break stuff. And humans could be users, or they could be you making some changes, or maybe your friends who are running Puppet on the fleet or something like that. So the deploys are the obvious ones, right? Everybody likes to talk about the fact that deploys often cause problems. And that's true, but pretty much any change can cause problems. The vast majority of them are safe. People run rm-rf all day and manage not to delete their entire home directories, but every once in a while they do, right? So we generally, modern view of safety in systems is that people are actually pretty safe, and that the systems are just not safe enough to help them. So we also need to be paying attention to things like change management, or feature flags, or scaling up and scaling down, DNS shifts, things, even social constructs. Like, imagine that, if any of you work at Apple, like, imagine if nobody told you about the big Tuesday event where you announced the thing, and suddenly all your systems are looking extremely weird, but no one told you that a lot of people were going to start coming to look at the new thing, right? Like, that's going to be pretty frustrating. So another big part of this that's important is automation. So automation we tend to think of as, well, we're going to automate it and then we're going to walk away. There's a really good paper called The Ironies of Automation that points out that really when you automate things, humans become actually much more important because automation has this pesky habit of giving up. Like if you think about like a self-balancing robot or something, like the robot's cool as long as it's unbalanced, but when it suddenly becomes unbalanced, the human's not going to be able to help much at that point. The robot's going to fall. There's not much you can do about it. So we need to avoid the human being out of the loop in the situation when automation fails, which means automation even needs to be heavily instrumented and provide information back to the user. So this brings us to feedback. We do not have enough feedback in the tools that we build. I'm complaining about this even as a vendor. Even the one that I represent doesn't have enough feedback. We need to find better ways to get more information about the change in our systems back to our end users, and our end users being our peers and teammates that operate these systems. These things need to be toggled on and off easily. We don't want to bombard them. We don't want to like have the screen flashing all the time, showing them alerts going off. We need subtle ways to show them the tremors and the shakes in the system so they can see problems as they start to occur or diagnose them as they go backward, and they should be easy to toggle on and off and move around. We need to avoid purely analytic interfaces, like just telling someone, oh yeah, you can go over here and run this SQL query that shows you all the deploys that happen and then filter by this. That's not what people want to do. They don't want to snap out and go into an analytic mode. They want to stay in a perceptual mode of looking at the user interface and seeing what's happening. Something that I feel pretty strongly about is like we've got all these alerts that are firing off and like going to Slack or going to email where you're totally paying a lot of attention to them. Instead, why not direct those signals back into the UI? Can they be showing up in some of our charts as subtle reminders that, oh look, garbage collection ran kind of hot there for a minute, but then it faded away afterward. That's really important information when you're trying to backtrack and figure out what happened after the fact. All right, so we've talked about a bunch of stuff here. We went through 6 points in 24-ish minutes. How do these things actually improve your observability stack? I told you a bunch of stuff, but I want to make sure that you see concretely how these can actually help. I reorganized all these slides right before this talk, so if I get them mixed up, I'm sorry. No, we're doing good. So why does promoting the work help? The number one way is just awareness. People that know, if they suddenly find out one day, if they're looking at a sheet and they see we're spending this much on a bunch of instances running something called Prometheus, why? They need to know about that work ahead of time. If you're promoting and sharing that work, then they're going to be less surprised by it. If you've ever studied biology, you may have heard of a word called stigmergy, which is how uncoordinated systems like ants figure out how things are going on. Like if an ant marches off and finds a cookie and then marches back with a cookie, that ant leaves things in the environment, pheromones that say like, hey, I found food over here. And other ants are like, I like cookies. So before you know it, they're all off getting cookies too. And so this is a way that if you're showing success and you're showing good output from your work, then other people are going to pay attention to this too. No press is bad press. Even being associated with incidents is helpful because I can tell you observability usually, I have caused incidents as an observability team, but it's very rare. So you're probably not causing them. So even being associated with something as nail-bitingly frustrating as incidents can be okay. If you're in leadership and you're in this room and you want observability to be an important part of the stack, you need to be promoting that work. What are you doing to lift that work up and say, oh, look at this cool work that this team's doing or that this engineer is doing. This is really helpful to the org, and it's really making our users safer and making a better product. You have the power to do that. We can teach the basics. People learn by doing, not by reading. But if we get them familiar with the topics, they're more likely to know where to go whenever they really need to use these tools in anger. Be sure to establish how you do it at your org. Everybody does it a little bit differently. You probably got a lot of cool tricks and stuff internally that make this stuff automatic. And then this also is a big way to avoid being frustrated, because one of the most frustrating things is when you are dealing with a problem and someone goes, oh, well, there was a dashboard for that. That just makes you want to punch people in the face, right? That's not like a really good answer if you've been dealing with it for a couple of hours. So system stretching, finding ways to use this data to sort of feed back into the system to make the system more resilient and safer. You're collecting a lot of data in these services and in this stack, so if you can find ways to sort of get more revenue out of that data, so to speak, by using it for other purposes, that's really great. But you're also able to ultimately, hopefully, make the system and make your product better, more resilient, and safer for your users. And then optimally, people are using this on a regular basis, which encourages them to get better and better and be more practiced so that when they're dealing with incidents, they know what they're doing. Measure the usage, know what it costs ahead of time. Don't be surprised by that conversation. We owe it to the company to spend the money wisely, so we should be making sure that we're doing a good job there. If you have systems that are especially risky because maybe they're new or they use novel techniques, monitor them closer. If you have some systems that are directly user interfacing, that's probably something else that's risky. If the system has been operating fine for a long time, maybe that's a time you can dial it back. That's definitely something you should know. Like, can we take away some monitoring of certain systems or some data, some telemetry volume or something to that effect? And you definitely want to be prepared when finance comes calling. You don't want to say, let me get you those numbers next week. So In our incidents, we need to make sure that we are improving how effectively we measure them so that the observability stack can help, and be sure to examine success as often as failure. And this also will generate lots of interesting questions. Use the incident management process to get information that you can feed back into the stack. It's a great source of those problems. And lastly, we need to instrument change better. Change is usually the start of the problem. I know most of us, when an incident happens, immediately go, who deployed something? Who changed something? Who ran Puppet? Who changed a feature flag, right? Like all these things are the social things you need to know. And these are also terribly small volumes of data. Like these are not things that happen a billion times a day like many of our metrics. And ultimately, you want more change. If you are more agile and able to ship product faster, that's ultimately something that you can feed back to leadership and say, hey, look, since we did this, we've been able to improve the rate of change, but the number of failures, the MTBF as it's often called, mean time between failures, is lower. All right, so this is the slide if you just want to snapshot it and see the 6 things all in one place: to promote the work, teach the basics, stretch the systems, measure your usage, track need, and instrument change. These are the 6 things that I encourage you to focus on. Again, these are largely social, not much technical about this. I think I have one interstitial slide that I'm going to, this first. So some or all of these, by the way. You don't have to do them all. I'm not gatekeepy about it. Maybe you have some related things, but pretty much any one of these done, or a little bit of all of them, should result in a much more rigorous, but definitely a much more valuable observability program. And I'm going to let this slide linger for just a little while. These are citations. If you're interested in some of the, like where some of this material came from, I encourage you to take pictures of this slide and check out some of these papers. I'm a big fan of the top one. Nora Jones's talk, also plugged that. That was just a few weeks ago. Very good talk at Monitorama. And then also Wikipedia for thoroughness. But thank you so much for giving me the opportunity to talk today. If you want to talk about any of this stuff, I'll be here all week. You can talk to me on the Twitters, or you can go to my website at onemilgen.com, where I write about some of this stuff periodically and somewhat randomly. Thank you. Enjoy the conference.